In this second section we're going to look at surds. Surds are just numbers that involve irrational roots. They generally appear as square roots of numbers. Numbers that won't end if you write them as a decimal. The surd rules are the root of a plus b is root a times root b, and the root of a over b is root a over root b. We can use these to simplify surds, as in example 1. To simplify root 50, we have to split 50 up into the product of two numbers, where one of the numbers is a square number. So 50 can be written as 25 times 2. We can now write this as the root of each number together, and so because 25 is a square number, we can take its root, and we've simplified root 50 to 5 root 2. Part B. This is the second result. If we take the root outside of both numbers, we can now simplify 15 over 3 down to 5. So the answer is root 5. If we have a number such as 5 minus root 3 and another one 5 plus root 3, because the sign in front of the root changes, and that's the only difference, these are called conjugate pairs. And these are useful because when you multiply conjugate pairs together, you'll get a rational number. We're going to show this in example 2. We're going to multiply these brackets out using a table. So the first bracket goes down the left and the second bracket goes on the top. 3 times 3 is 9. 3 times root 2 is root 2. 3 times minus root 2 is minus 3 root 2. And then you have to take care, minus root 2 times root 2 is minus 2. If we list these four parts out and then collect terms together, we notice we have 9, take away 2, 7 for the rational part, and the 3 root 2 disappears with the minus 3 root 2, so the answer works out to be 7, a rational number. This can be very useful when you come across a fraction with surds on the bottom. If we want to make the denominator, the bottom number, a rational number, we can multiply the top and bottom of the fraction by the denominator's conjugate, as in example 3. We're going to try and rationalise this fraction, meaning we're going to remove the surds from the bottom of the fraction. The conjugate of the bottom is 2 root 3 minus 1. So we multiply the top and the bottom of the fraction by this number. We're going to do each multiplication in a grid. The first one is 2 minus root 3 multiplied by 2 root 3 minus 1. If we multiply this out and then write the terms down, we can collect the rational and irrational terms, and we get minus 8 plus 5 root 3. If we now multiply out the bottom brackets, when we collect the terms together, we find we've got 11. So now we can rewrite the fraction as minus 8 plus 5 root 3 over 11. A fraction that has no surds on the bottom. Here is a typical exam question for you to try. Press pause, and once you've finished doing it, press play again to see the answers. Part A. We're going to multiply out the brackets in a table. We get 5, 2 5, minus 2 root 5, and minus 4. If we write these down and collect them together, we see we get the answer 1. In part B, we need to write both numbers inside the root sign as 2 times another number. So 8 can be written as 4 times 2, and 18 can be written as 9 times 2. We can now split these numbers up and take the roots of the square numbers to get 2 root 2 and 3 root 2, which we can put together as 5 root 2. We're going to finish with the key points from this section.